Hey Longhorn family, it's Mr. James here, and today we're going to discuss our topic in Unit 6, which is fractions. And we're going to discuss the importance of fractions and how we can represent them given several different models. All right, so let's take a look and break down the TEKS. Taking a look at our TEKS, you can tell we are working with TEK 3.3a. TEK 3.3a states that students will be able to represent fractions greater than 0 and less or equal to 1 with denominators such as 2, 3, 4, 6, and 8 by using concrete models such as pictorial models and number lines. So we're going to talk about fractions and what they are and basically and essentially what they mean. So first things first, we got to break down what a fraction is. All right, so what is a fraction? Well, the definition of a fraction is a fraction expresses, which means shows, equal parts of a whole or a set of objects. So I'm going to write that here. What is a fraction? And I'm going to simplify that there. Fractions represent parts of a whole. But with this word parts right here, what you have to understand is fractions have to have equal parts. If a fraction does not have an equal part, it is no longer considered a fraction. So I'm going to show you an example of a fraction here. Take a look at this. Here, I have a box. We'll call it a little chocolate bar. And as you can see, I went ahead and I split this up. Now, instead of saying split, you're going to say another word, and that word is partition, which we're going to get into in just a minute. If I asked you to tell me what this fraction is of the shaded parts, you would say that this fraction is equal to 1 over 4. Okay, so if I ask you for the shaded parts in blue, you would say 1 over 4. Now, this is 1/4 of the whole is blue. Now, what if I asked you to represent the fraction of the purple parts? You would say 1, 2, 3, 3/4 of the fraction is purple. Now, you may be wondering, what do these numbers mean? Well, in second grade, you were working with fractions, but you were working with fractions in a different way. You weren't really used to the symbol that you're seeing here on the screen. Let me go over what that symbol is. There is a formula for a fraction, and that formula is simply parts over the whole. Okay, I want you to keep this in mind as we work through this unit. So take a look here. If I have 3/4, what you need to remember is that the 3 represents, in this case, how many parts, I would say, are being counted. Okay, and then the bottom number would be the total number of parts. But I still don't know what these numbers mean and why they're aligned like this. Well, at the top, you have the numerator. And over the numerator, or at least I would say under the numerator, is the denominator. So you want to remember that the denominator is the total, and the 3, or at least the numerator, represents the number of parts total, and the 3, or at least the numerator, represents the number of parts that are being counted. So parts over whole. Remember, this is the parts over the whole. What do you mean by whole, Mr. James? Well, how many total parts do we have in this model here? 1, 2, 3, 4. That makes the whole right there. You can also represent fractions in another way. Here's an example. Here I have a triangle, right? I'm going to partition this triangle just like this. In this case, I'm going to shade in this part of the triangle. Would you be able to tell me what the fraction of this triangle represents? It represents what? Half. Half of the whole. So I'm only eating half of this pizza out of the whole pizza. All right, so you want to remember fractions have to have equal sizes. It has to have equal sizes. If it does not have equal sizes, like I said earlier, it's no longer considered a fraction. For example, I'm going to show you an example of fractions that we do not do and fractions that we could do. So here is an example of a fraction that is possible for us to do. I'm going to use a circle in this case, and I'm going to split this up into eighths, okay? and I do it just like that. How many parts total do I have? I have 8 parts. Now, if I tell you to do this, 1, 2, 3. Would this be a fraction, or would that at least be considered a fraction? Yes, it will. It has equal parts, and there are 3 out of 8 shaded. Now, something you don't want to do is this here. I'll use a bar model for an example. Is this a fraction? Is that a fraction there? No, it's not a fraction. Why? This is not a fraction because it has unequal parts. All parts must remain equal in a fraction, just like this here. So you can represent a fraction in several different ways. Now, the fun part about fractions is you can decompose them. So if I were to give you a fraction like this at the top, okay, what vocabulary would you use here? There are certain vocabulary words that you have to remember when it comes to fractions. For example, you have halves, and I'll write those over here on the side, and I'm going to scoot this over. You have halves, thirds. Okay, what else could we use? Fourths. I'm going to scoot this over a little bit more. Fifths. Sixths. Sevenths. Eighths. And then you can continue with ninths and tenths. So back to this question here. What is this? Okay, this is 6 over what? 8. Okay, if I asked you to decompose this fraction here, you would use a unit fraction. Remember, a unit fraction is simply a fraction with a numerator of 1, and it represents one part of all the equal parts. Okay, so I'm going to use unit fractions to decompose this here. I'm going to add up all my numerators, which is 1. And how many numerators should I have at the top? 6. So I'm going to draw 1 plus 1 plus 1, 1, 2, 3, plus 1 plus 1, and plus 1. Your denominator stays the same. So in this case, over 8 for every fraction we wrote. Okay, so 1 over 8 plus 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 1 over 8. 1, 2, 3, 4, 5, 6 equals to 6/8. So your denominator stays the same and your numerator is represented with ones. You could also do the same thing as well. If I were to give you 3 over 4, the way that you would decompose this, you would do 1/4, okay, because we're dealing with fourths here, plus 1/4 plus 1/4, 1, 2, 3, okay? So I have 1, 2, 3, that makes 3 as your numerator, and 4 stays the denominator, which stays the same. That is how you decompose a fraction. Now, I want to model this 6/8. The way that I can do that, I'm going to draw how many total parts in this bar model? 8. Now, when it comes to using a bar model or using any type of rectangular model to draw parts, and you have to partition this box up, you want to make sure that you go one number back, and that's how many lines you draw. So if I go one number back, how many lines should I draw? 7. That makes 8 parts. 1, 2, 3, 4, 5, 6, 7. All right. How many should be shaded? I want to represent 6 for my shaded part, so I'm going to shade in 6. 1, 2, 3, 4, 5, 6. Okay, so there are 6 out of 8 shaded, and if I tell you to represent the fractions of parts that are not shaded, you would say, okay, that will be 2 out of 8 parts that have not been shaded. Same thing goes for this one right here. If I were to do this, I can represent this by 4. Remember, we go one back when doing our lines. 1, 2, 3, that makes 4 parts. I shade in 3. 1, 2, 3. I have 3 out of 4 shaded.